Hey everyone, in this video we'll discuss that how we can add an element at the end of a doubly linked list. Let's start. So for adding an element at the end of a doubly linked list, we have to put some conditions. In singly linked list, we have to traverse up to n-1. Whenever we'll see that temp next equals to null, then we put the value. But in this case, we have to move two pointers. So what are those? One is prev and another one is next. So in doubly linked list, we have to move two pointers parallelly. So for inserting any element at the end of the list, what we have to do, at first we have to allocate the memory. So at first what we'll do, we'll set the prev and next pointer as null. So at first we'll set the prev and next as null, then add the last node address into the memory node prev. So we have to add the last node address which is the last node of our linked list into the new node prev. Let's say that this is the last node. This is the last node. It has some address. We have to set this address over here, and then what we have to do, we have to add the memory node address which is the address of temp into the end of the last node. We have to, like, let's say that it has an address ffx. We have to set this ffx over here. So we'll discuss about that in detail. So at first we'll do, we'll allocate the memory, then we have to move two pointers. One is prev and another one is next. So let's look at the dry run. So as you can see that at first we have a head pointer. We have to add a value over here. So what we'll do, what will be the condition? So at first what we have to do, we have to allocate a memory. Let's say that we have allocated a memory that is called temp, and it has some value that is 100, and it has some address, let's say fff6 or something. Now what we have to do, at first we have to traverse our reference pointer to the last node. So what we have to do, we have to traverse to the last node. Now you can see that what is the address of this node. Address of this node is fff0. What is the address of this node is fff2. Its previous pointer has its previous node address, and it has its next node address, that is fff4, and same goes for this node as well. So at first what we have to do, we have to traverse our pointer up to here. We have to traverse our pointer up to here, reference pointer. So what will be the condition? The condition will be t next not equals to null. So it means this is the t next, right? Let's say that we are at this pointer. Let's say that we are at this node. Let's say that we'll assign that into a reference pointer head. Then at first we'll check that t next not equals to null, t next not equals to null, t next not equals to null, and in this case this t next not equals to null will not satisfy. So we'll terminate the loop, and here we have a t. So what we'll do, we will assign this value here. We have to assign this node address, that is fff6, here. So what we'll do, we will just write t next. We have to write t next equals to temp. So whenever we'll write t next equals to temp, it means here we'll have fff6. So this node will point to this node. So this thing is same as our singly linked list. But what is the other modifications that we have to perform? So we have to set this address over here. So how we can set that? For that we have to write temp prev equals to, now where we have this fff4. So we have this fff4 stored within a t. So what we'll write? We'll write temp prev equals to t. It means here we'll have fff4. Now this node will be pointing to this node. So here, this is how we can connect. So this is how we can add an element at the end of a doubly linked list. If you have any doubt, just write in the comment section. So let's look at the algorithm. At first what we have to do, we have to allocate the memory using, like, by calling this function we are allocating the memory. Then we are taking this data, you can assign that, or you can take this data from the user. You are assigning temp prev equals to null, you are assigning temp next equals to null. And let's say that we don't have any value within our head. Then what we'll do, we'll just assign temp over here. So if we don't have any value, then we don't need to traverse, right? How we can traverse? Because our head is null. So if our head is null, then we'll just write head equals to temp. Now we'll talk about the else condition. So let me draw a diagram. Let's say that we have this 4 or 3 nodes. We have these 3 nodes, and let's say this is the memory address of the first node is A, memory address of the second node is B, this is C. Here we have B, here we have C, here we have null. So what I have discussed earlier, that we won't move the head pointer. We'll just take a reference pointer which is node T, which will be pointing to the head. So it means it's pointing to the same node. Now we'll check the condition. So what is the condition? The condition is T next not equals to null. It means at first we'll check what is the T next. T next is B. Now it's pointing to the first node. So we don't have null over here. So this portion will be executed. Then we'll just move T to the next. Now where T will point? T will point to this node. Now in T next we have C over here. So this portion will also be executed. Then we'll again move the T node. Now T will be pointing to the last node. But in this case, at last we have null over here. So this portion won't be executed. The loop will be terminated. Now what we have to do, previously we have created a node, right? Let's say that this is a node. We have some value 10 over here, and let's say the address of this node is D. Now what we have to do, and the name of this node is temp. So we'll assign temp prev equals to T. It means now within T what do we have? We have C, because T is a reference pointer. Don't get confused. So T is pointing to this node. The memory address of this node is C. So at the temp prev we'll assign C. So we have assigned C. So we have done our first step. Then what we'll do, we'll just write T next equals to temp. So here where we have null previously, we'll just write the address of, we'll just assign the address of temp. So what is the address of temp? Let's say D. Now it will be pointing to the node which has the address D, which is the temp node. So this is how, and this node will be pointing to this node parallelly. So this is how we can add a value at the end of a doubly linked list. So I think this portion is clear. Let's look at the code. So as you can see that at first we have declared a structure. In doubly linked list we have 2 pointers. One is prev and another one is next. We have assigned the head as null. There is a create node. There is the insert function. So as you can see that we are taking the value from the user. We are assigning null in prev and next. At first we are checking that our head is null or not. If our head is null, then we are assigning that node into head. And within the else portion, at first we are taking a reference pointer, that is ref. Now we are checking that ref next not equals to null. We have discussed this thing previously. Then if that is not null, then we are moving our reference pointer, and at last we are storing the value. So in this case we are storing the address of the previous node, and in this case we are storing the address of the temp into the last node of that list. So I think this portion is clear, and this is a traverse function. So how many times we are calling these functions in insert function? 3 times. So let me copy this thing again, and let's say that we'll insert 5 times. So let me compile this code. So how many times I am calling this function? I am calling this function 5 times. Let's say 10. In this case our first node will go into head. 20, 30, 40, 50. So as you can see that we have successfully entered 5 values. So here we are printing all those values. So this is how you can add a node at the end of a doubly linked list. If you have any doubt, just write in the comment section. See you in the next video.